Today we will discuss the 100-page machine learning book. So what is machine learning? Machine learning is simply when a machine learns how to solve a practical problem by studying the data and building a statistical or simply building a model based on the data. So what this model does is it simply studies the data and based on that it solves the problem that we are facing. There are four types of learning. So simply machine learning is when a machine learns how to do a task and starts working and solving the problems or completing the task we have given. So simply we train a machine to do a job. So there are four types of machine learning: supervised, semi-supervised, unsupervised, and reinforcement. In supervised learning, your data has um, two main features. There is your x variables and there is your y variable. A y variable, also known as the target variable or the label, is the answer, is the thing you want to predict. And x variables, which will be many, are the variables you are going to use to predict the y variable. So the way this works is our model will study the x and y variables, understand the trends or the relationship between the variables and the variables and the labels, and on the basis of that it will create an equation. Then using that equation, whenever we pass a new set of x variables, it will pass it through that equation and predict the probability of the y variable being true or false based on what type of y variable we have. There are many types of y variables. There is categorical variable, there is binary variable, and there is continuous variable. Binary variable is simply when your y variable has only two outputs, 0 and 1, true or false, yes and no. These are examples of binary variable. Categorical variable is when they have multiple, more than two answers to the target. So when your y variable has multiple categories like a rainy, sunny, humid, cloudy, like weather types, there are 5 6 types of weather. So this is a categorical variable. And then there is a continuous variable like house prices. It could be 59,250, it could be 60,250. There are a lot of possibilities, infinite possibilities you may say, but we need to find which possibility has the highest probability. So these are the three types of y variables. Now, in case of a binary variable, the goal of our supervised learning model or algorithm will be to use the data we give it to study the data we give it, understand what is the relation between the x variables and the y variables, the trends. So it will simply analyze every x variable and see what is indicative of this y variable being a 1. So when is y 1? Okay, so this variable, for example, in our insurance example, if you want to predict if someone will buy life insurance, if the age is higher, people tend to be more, um, you know more, they tend to buy the life insurance more often. So it will study that data and it will get to this conclusion that older people tend to buy the life insurance more commonly. So it will produce a model. Now this model will take the age of the person as input, and in the output based on the age it will predict the probability of the person buying the insurance. This is a very simple example of supervised learning algorithm where there is only one variable, one x variable, and a binary y variable. But there are much larger and different uh, problems that we can use supervised learning and solve. For example, you can give a data which will describe a person's health by giving uh, the health test results and the statistics of the person, and the model will output the probability of the person having cancer. This is a more um, difficult, more larger supervised learning usage, right? Because it is not as simple, it's a more complex use case. Unsupervised learning is used when you have a collection of unlabeled samples. So you don't have an answer. You are not trying to exactly predict an answer. You are just trying to understand, the relationships between the variables. So you are trying. For example, there are many methods in this. So all you're trying to do is you're trying to understand the relationships between each variable to each other. So for example, one of the methods used in unsupervised learning is clustering. In clustering, you cluster all data points who are similar together. So there might be 3 or 4 clusters. So there might be 3 or 4 different types of data points who are very close together. For example, in customer segmentation, we try to cluster which people more often buy um, groceries, which people more often buy, you know, health and beauty products, which people more often buy, um, you know, home products, office products, and then based on that we create clusters. Okay, so if this person is like has these qualities, or he is he is making yeah, so simply by use, or in YouTube video recommendation. So what YouTube does is it takes your past history, the videos you have watched, and uses clustering to find out which customer segment you fall in, which viewer segment, to find out which type of videos to recommend to you. So do you like watching videos which are based on tech? So it checks your features, your history, the videos you have liked, the videos you have subscribed, and it tries to fit you in a cluster. Now if you are not in the tech cluster, then it will know that you are not interested in tech videos because you haven't liked or subscribed or watched them. So it will not recommend tech videos to you. It will recommend the videos that you like by clustering you with a like-minded segment of people, and you and that those like-minded people will get the similar recommendations, which will be more appealing to you, which you will more likely want to see. Semi-supervised learning is when the data set will contain both labeled and unlabeled examples. Now usually there will be very few labeled examples and a lot of unlabeled examples. The hope here will be that using many unlabeled examples, the mod will help the model to find the algorithm to find a better model. Now this might sound like why will giving it less data make it improve? Well, that is mainly because of two reasons. First of all, in supervised learning, you need to hire people and label the data yourself. Someone needs to label the data, write the answers, right? And if there is any error in that, then it could cause problems. Plus it requires a lot of capital to hire these people who will hand label the data. In semi-supervised learning, you solve that problem because only a few records are labeled and then the rest are unlabeled. So the way this works is, one of the ways it's used is that you will take the little like 10% records which are labeled, give it to a model. The model will train itself on it, and then based on that, the other 90% unlabeled will be made predictions on. So for example, it trained itself on the 10% data of, once again let's take the insurance example, and then it made predictions on the other 90% of the data, whether these people are going to buy insurance or not, because we don't have their labels. And then there is a confidence score that it will give. I am this person confident that this person will buy the insurance, because you can be very confident that a 18-year-old or a 20-year-old is not going to buy the insurance because he probably cannot afford it, or he probably doesn't understand the importance. The same way you can be very confident that a 50 or 60-year-old will buy the life insurance, right? So using these statistics, it will give a confidence score, how confident it is in its predictions. And then only the predictions in which it is very confident, like for example it is sure, 90% sure that this prediction is right, only that set of predictions will then be turned into labels. The rest will still remain unlabeled. So if it is sure that this 18-year-old is not going to buy the insurance, it will give it the label 0, because it is sure he's not going to buy it. But for someone it's not so sure about, okay, 60% this guy is going to buy it, but then there's a 40% chance that he won't, it won't label him as either a buy or a not buy, because it's variable, there is a lot of chance involved, right? It could be either way. So and then it trains once again. So once you have labeled some data, so first you had 10% labeled, 90% unlabeled. Now once it made the predictions, now it has 20% labeled and 80% unlabeled. Now it will train itself on the 20% labeled data once again. Then it will again make predictions on the 80% unlabeled data, and so on. There is, you can do as many iterations of this as you want, but the common number is 10. So after 10 iterations, your model will be pretty good at predicting the data. Finally, there is a reinforcement learning. Reinforcement learning is when the machine is constantly, it is living in the present, so it is constantly taking in data from, from its surroundings, and then based on the data it takes, it then executes actions, and different actions bring different rewards based on what result there was, right? So simply the machine is constantly present, is aware of its surroundings, so the data is constantly coming. Based on that it will take an action, and then based on what was the outcome of the action, it will get either a reward or a penalty, right? So for example, some examples of this are when you teach a machine to play a game like chess. So it's constantly looking at the board what the opponent is doing. Based on that it is making its own moves, and then based on the result of its moves, it is either, so for example, if it did a move which costed some pawn, or it costed it and it wasn't a good move, it will get penalized, so it will lose some score. And if it is and if it performs well, then it will gain some score, some reward. So based on that, based on, as its constant analysis, okay, in this condition the I played this move and it was wrong because I was penalized. So based on this, all the data that will, be collected, it will analyze and learn how to play better over time. But we won't be we won't be focusing on reinforcement learning in this book.